All right, so we're going to go ahead and get started with our first presentation, and this is going to be from a couple of our users. So I think we might have a slide set up, and so we're joining in Chris and Ben. So let me just tell you quickly what I know, and I'll give the quick introductions. Chris is probably the first user that I reached out to after being here at Timescale. I was in community Slack, and he has just been, honestly, in my year of being a Timescale employee, he's been a great community member, super helpful to many people within the community. And I remember probably 2 weeks in, I was like, I got to meet this guy. Where's he from? What's he doing? He's been really helpful, and I appreciate that. And likewise, if you spent any time in Slack, in our community Slack, you've certainly seen Ben Wilson as well. So these two gentlemen have just been really giving of their time. And, as a developer advocate, just someone who wants to see people be successful, it's been really fun to watch them care about other people and just give freely. It's not always something that you get to see. So I appreciate both of you guys for doing that. So thank you. So Ben is a full stack developer, leading member he's a leading member in the Elixir community, something that I have no experience with. So it's been interesting to hear him talk about that some. He loves open source, is a contributor there and author. He's actually the founding member and CTO of CargoSense, as you see on the screen, and he's a co-creator of the GraphQL Elixir implementation. So GraphQL, man, has exploded certainly in the last couple of years. Chris is I think I have this right, Chris, right? You are in Germany. Is that correct?
I am.
Yeah, for some reason, all of a sudden I was second guessing myself. He's the co-founder and chief software magician at clevabit, and he's really an open source enthusiast, full stack developer, really across every portion of hardware and software. And every once in a while, if he shifts, you'll see a nice little homage to computer history behind him, or follow his Twitter account, and you'll see lots of cool, fun hardware. So, gentlemen, thank you so much for joining. I appreciate it. I'm just excited to hear you talk a little bit, and we'll chit chat about what's going on. I love the emojis, and I love the titles. So, what do you have to say?
Ben, you want to go first?
Sure. Yeah. So CargoSense is in the logistics visibility space. Logistics has actually become kind of a hot topic. It's flown under a lot of people's radar until 2020 and some of the stuff right now. But we work with companies that have logistics processes to instrument those processes. This could be IoT devices. It could be telemetry from phones or any number of other things. And then we use that data to help people understand what's going on in their logistics process. Is it going according to plan or not? And if it's not, a workflow around figuring out what's going wrong, how to handle with it, how to communicate to the relevant people. We've been doing this for a while. We've been on Postgres from day one because it's rock solid. It's a great feature set. Its performance continues to improve. And so that's what we were on. And we're actually a case where we had billions of rows in a regular Postgres table, and we were 100% running into, when I first saw the first Timescale blog post where it's like, hey, as you try to insert stuff into a Postgres table, it will get slow because of reasons, right? And we're like, yes, definitely. And so it'd been on our radar for a while, but we hadn't quite hit database tech is something that, if you've got a lot of data, migrating is not something you can kind of do overnight, but we started putting it on our roadmap, and we switched over a little over a year ago. We went to what was then called Timescale Cloud and is now called the Managed TimescaleDB service or something of that sort. And we've been there for the last year. It's been great. It has been a really great tool for us. The community has been great. We've really enjoyed interacting with Ryan and Lorraine and others. That's kind of us and how we started using it. I'll leave it at that for the moment and elaborate as things make sense. So take it away, Chris.
Sure. Well, I mean, what should I say after all the blushing words that I already got, right? So with clevabit, what we do is we're trying to build a system that optimizes animal welfare and helps farmers to optimize growth, but still making sure that we're getting a little bit away from this like hardcore industrial kind of animal growth, right? How we want to do that is there's a lot of organic labels, at least in Germany and the European Union. I'm not sure how it is in the States though. But in Europe, there's like no real good organic label. So what we want to do is we want to trace the whole chain, basically from laying the egg all the way to the hands of the consumer, and be able to tell the customer, hey, this is exactly what happened. That is how long your chicken was transported. That is your CO2 footprint. This is the feed it got, and all this kind of stuff. Well, and for that reason, we need to collect lots and lots of data over quite a while of growth and lifespan of an animal, depending on what kind of animal it is. And well, we're not handling elephants or unicorns yet, but we're working on that.
That's awesome. So Ben, I know you said, and Chris, feel free to pipe in as well. You've always been on Postgres, and so you had that similar moment that I know I've experienced over many years. Now, I've been in both SQL Server for a number of years and in Postgres as well. As I said to Ajay, I was kind of one of those initial haters, right? Like, there's no way once you get past some scale that this is really going to work. And then we found Timescale, and it seemed to be that meld that I needed between this is where all my business data is, and I just want to query my time series data, and this kind of works. This is pretty amazing. So what was that journey like? How did you get from where you were to like, yeah, this might be the next step?
Yeah, that's a great question. Part of it, I'll kind of come at it maybe from two angles. One has to do sort of with like things that motivated our initial move, and then like things that we've now done after that move that I feel like have been enabled really well from the Timescale side. So the motivation, especially for the early phase of CargoSense's life, we were dealing a lot with like data loggers in the pharma space. And so we would get kind of the data in bulk, and we could do inserts in bulk. And we're talking like hundreds of thousands, millions of readings at once. And in those situations, as we started to grow our data set, you would kind of do all the analytics around that in one go. And so data was sort of at rest a lot, it would get read for analytics, and then just kind of set aside until the next data logger came in. And we weren't having to sort of we could do things as Postgres started to groan under the weight of the data we were doing. We could do things like pre-generate all of our graph data into like for our charts, right, on that we'd display. We just like pre-generate it into CSV files we'd put on a CloudFront based S3 bucket and stuff, so that you could just like hit the page, not hit the database because that was getting slow, pull down the CSV file. You could do this stuff, right? And
for sure.
But as we started doing more real-time devices about 3 years ago now, started focusing more on the logistics process and not like product quality, that those were obviously infeasible. We knew they were hacks. And so we evaluated some non-Postgres based solutions for this stuff, but sort of two considerations had us favor Postgres. One of them was sort of practical, and if you're going where we were a relatively small team, we wanted to move quickly. Adding another database that's going to be a frontline primary data store for this stuff is an ops cost, and like I was ops, so like did I have the time to handle another database? Did I have time to deal with the challenges of being unable to write transactionally between this other database and our sort of primary business logic database, et cetera? Those were concerns we had, right? The second thing was just that, a lot of the, as we started looking at Timescale, a lot of the capabilities made a lot of sense for us, especially as we were dealing with more real-time data. The access patterns fit kind of the Timescale hot chunk thing. With data loggers, it was weird. We get data from any time in the last year, right? And with which would still be fine with Timescale, but especially with real time, where you're kind of writing to the hot chunk, reading from the hot chunk, it was like, oh, this is going to scale really, really, really well. And so we started testing it. We migrated over a year ago, and then since then, this is before compression, right? And then like compression came online, and we started using it, and that really, I had high hopes, and it exceeded them. Like we're seeing 90+% compression on our tables. And this has two big benefits for us. A, we're not having to have a multi-terabyte Postgres database. We can still be in the sort of hundreds of gigs range because all this older data is staying compressed, even though we have like 10 times as much data as we did when we started, and we're using like half the space that we were using before we went to Timescale. So that's been great. The people get concerned, I think, because when you think of compression, you think of like, okay, well, accessing like a gzipped file is slower than accessing, not a gzipped file. So there's going to be issues. But because it has the limiting factor in a lot of Postgres stuff is your IO off your disk. And so if you're going to be fetching data that's compressed, this is not archaically compressed where you're going to have to then burn a bazillion CPU cycles to get at it. Rather, it's just sort of, the docs are great. They actually go into a lot of detail. But you can just fetch, instead of, if you're trying to fetch 100,000 rows from a time span, instead of getting 100,000 rows off disk, you can get maybe like 100 rows. And then that pulls into memory, tiny bit of decompression, your app can process it. We've been really impressed with that performance. So that's awesome. Yeah, that's been kind of the journey. We've started using some of the hyperfunctions more. And I think there's how you access the data is a thing that we've seen in the Slack a lot. There's definitely groups of people that are trying to almost always look at things in aggregate. What is the average of all time for X, Y, and Z? What is the sort of very summary data all the time? We're not so much that. We're generally trying to like pull data on a device. We might do some transformations, but we're sort of taking a time series and emitting another time series. We're not generally rolling up time series into singular values. And so those helper functions for that have been really great. We look forward to the toolkit. That's really awesome as well.
Fun stuff in there for sure. We're going to hear more about that later. So there's a bunch of great blog posts. Gotten a lot of good feedback, so I'm excited to hear what you guys do. Chris, I've seen a number of times we've been on video calls at points to see clevabit's tables and what you're doing there. What are some of the challenges you've had thinking about how you design your schema? What I know that's been some of the things you've talked about coming from a JSON background sometimes we have some of this data that we don't want to have in columns necessarily. Can you just talk a little bit about some of the challenges you've had around schema? I know we get lots of questions about that.
Yeah, well, to be honest, I still don't think we found the good solution.
That's okay.
So for us, the problem is we have an open platform and we don't know what data comes in. So when we started out, for us, the biggest problem is like, how many different data types do we need to support? So that was when the JSON-B one column and a lot of data solution was born. And to be honest, ever since it works, it's not as slow as you might think, which is probably because it's JSON-B and Postgres is just awesome. But it works pretty well. We have a couple of helper functions where you see a specific value type, what data type it should be, like it's a uint or a float. And then we have helper functions to extract the data straight away, and they're implemented in a way that it looks a little bit nicer from the query point of view. So you don't have to do this like massive accessing thing and all the casting, because I think that is like the worst and the ugliest part about JSON-B, that everything comes out as a string and you have to cast back and forth kind of.
Yeah. Well, one of the things. Oh, go ahead.
No, just ask.
No, I was going to say, on top of that, I think one of the things that we, part of the schema discussion also ties into things like other things we talk about often. I know, again, both of you have talked about it. I see you helping people with it. I know you've thought about things like chunk size. How does that impact, your queries, and how does it impact compression? What is the right way to approach that? And, so those two things are kind of tied together. What's been some of your thoughts?
Right. Well, so let's quickly jump back to the other discussion, because I think there's a couple of more ways to do that. What we're currently we have to migrate quite a few data, but we figured out that for us, 5 or 6 data type, I have to lie, I think it's 6, is basically what we need. And one of those is JSON. So if anyone wants to store anything that doesn't fit into the other 5, yeah, just do whatever you want. And now what we figured out is it's probably better to just use nullable columns, because they're great. It's a little bit easier to access. The interesting thing is we couldn't find any speed difference so far. And you may remember we talked about that in the past, and nobody can explain me why, because everyone expects it should be faster to just use columns instead of JSON-B. But it doesn't happen. What we never tried, and I see a lot of people asking for that, making every single possible value type, whatever you want to call it, a column. And I'm not sure I'm a big fan of that. But I'm happy to hear different. Ben, if you have...
Yeah, we have like different hypertables for the kind of data. So we have like a float values table, a geolocation data table, a string value data, a sort of dedicated key value hypertable. And so we avoid the null columns. It does mean that because for us, we don't always get at a timestamp 9 values across that timestamp. It kind of different devices will go into logging modes where we get like float temp data, but not GPS data and that sort of thing. So it kind of comes in piecemeal. And so we have distinct tables. What that means is our tables are very lean. They have like the recorded at, which is the time on the device, the ingested at, which is the time it hit our service, the value column, which is, float or PostGIS or whatever, right? And then what we call an element ID. And that basically is just a good old-fashioned big int foreign key to a table which really carries all the other information about like what kind of data is this? Is it temperature or humidity or whatever else, right? And that's kind of the and a payload ID. Payload ID helping, this has to do with a bunch of really interesting discussions around clock skew, tracking whether or not you've seen data before or not, and the sort of bitemporality of recorded data. But setting all that aside, that's it. That's the whole table, which lets it compress really, really well. We don't have these null columns, etc. I'm sure there's other ways to do it, right? I think we're all discovering that. We don't have to worry about nested data, right? So like if we had to worry about nested data, we didn't control things, we might have to create a sort of catch-all JSON-B thing. But that's what we did, is we just broke it into different hypertables depending on sort of the data type. But then there's columns that sort of help you understand, okay, this float value is measuring what? Temp, humidity, air pressure, et cetera.
Gotcha. So we just had a question, which as you were talking, I was thinking the same thing. So in your day-to-day of the application, then you already answered part of it. Compression's great because you're getting it, the data types segregated there, which is actually kind of, there's the question on screen in case you can see it. The second half is, how do you actually end up using those tables? Are you often joining between the hypertables?
Yeah, so that's a good question. It depends a little bit on what we are doing with them. If we're trying to do some kind of analytic that is going to be looking simultaneously at the temp data as next to sort of the geo data at the time, then yeah, we join on the recorded at columns, the device time columns, and then we can produce some result that is sort of like, what's the average temperature within a geofence, for example, right? That's a thing that we have to talk about. And so, yeah, we join the one against the other. That works great. As with all timescale queries, it helps it is very important to have some kind of time bounds you're pushing into those queries. But the joining part works super well. Don't have any issues with that at all.
It's funny. Like, you guys you're answering the question right before I get to it. Ben, you've brought that up often in community conversations. I see that. Chris, you have done the same thing. It's recognizing that as your data grows, doing a simple select something from, where ID and no time bounds, it's a partition table. The planner doesn't know how to go find information faster than checking every partition. And that's often not what you actually want. If it is what you think you want, then you probably need to stage something a little bit higher level as your data grows, because planning time and so forth is just going to...
Yeah, and this is sort of the trade-off. Like, I'll say one of the things that's very remarkable about Timescale is that, generally speaking, in fact, in every case that I've seen, things that our Postgres clients can just query the table and it works fine. They don't need to know it's a hypertable. They have literally no concept of that. It just works every time we've tried, which is awesome. And in that way, using Timescale does not require any major heavy lifting or huge changes in your application logic or anything like that. But the thing we have found very helpful is that because it's not one of the advantages of like a column dedicated database. There was a ClickHouse thing on Hacker News recently. If you're trying to discover the time bounds, like what's the first data point from this device and the last data point from this device, if you're trying to discover that and you have years worth of data in Timescale, that's not going to be that fast, right? Like you're better off with some bookkeeping tables and some bookkeeping columns that sort of track relevant time ranges. And I think my favorite illustration of this, if I'm not out of time, my favorite illustration of this is someone who came in to am I out of time, Ryan?
No, you go ahead and finish this. I have one last question for Chris, and then we'll wrap up.
All right. My favorite example of this is of someone who came into the Slack and with a very interesting scenario. They were doing simulations and they wanted to capture the simulated data in Timescale. And so their question was, hey, my time column is like frames into the simulation.
I remember this one
with Timescale. Yeah. And it was kind of like in the first glance, like not really, because it means you're hitting time zero like every simulation, and then you're not really actually growing in the chunks. But what we realized is there's the time, the human real world time that the simulation was run, and that always, advances. And so what they did is they had the time at which the simulation point, the wall clock time that it was generated, as one column, and that was the one they partitioned on. And then they had their other column, which was basically like simulation time. And this worked really well for them because they knew when their simulations were run. So the only bookkeeping they had to do was like when they started a simulation, they captured that timestamp when they in their simulations table. And when they ended the simulation, they captured that other timestamp. And then this meant that they could query their hypertable really, really efficiently. And like as you might expect, simulations that were run more recently were accessed more often than simulations that were run a long time ago. And so the access patterns suddenly fell into place. And that's really my biggest suggestion to people who are going to use Timescale is consider some bookkeeping tables so that it will eat up a tiny bit more space. You'll make it back 1,000-fold in compression. And that will help with better access patterns. And it'll help you not need to hit the hypertable if all you really want to know is like, when's the last time I saw a device? Just keep that in the devices table. Don't hit the hypertable for that.
There you go. So that's my last question to Chris. We do have to wrap up here in a minute. You were one of the earliest proponents, and you continue to do that. Talking exactly about things like bookkeeping. Everything doesn't have to be in the hypertable. There are ways. That's one of the other values and beauty of Postgres. What's your experience? You've done some of that.
Right. So we keep everything in the hypertable, but what we also have is for the initial dashboards, we have a couple of continuous aggregations, like give me daily values for the last 7 days for temperature, for humidity, whatever. But what we also need, and that is super important for our farmers, they need the last measurement for basically everything we need, well, for everything we measure. So what we do is we set, and it's probably not the best way, but it works for us. We have a database trigger that every time we add something to the hybrid table, we automatically update one of the bookkeeping tables, which is basically last measurement cache. Great name, I know. But that one has an index on device ID, value type, and the time, and you literally just query that. It's a nanosecond operation almost. And this is exactly what we need. And for the rest of the stuff, to be honest, as Ben already said, compression is great. We see the same thing around 90 to 92% compression rate, which is completely mind-blowing. I have to say, it's mind-blowing. When I saw it, I was like, yeah, okay. And query times are, as long as you have a meaningful time range, a fixed time range that you can query, it's a no-brainer.
Awesome. Man, I could talk to you guys for a long time. So maybe we need to just do another stream someday with that. It is something we're going to be working towards. So expect to hear from me. I want to say two things before we wrap this up. Number one, if you're watching or when you watch the recordings of this, when you see these two gentlemen in community Slack, please thank them. I've joked with both of you. You've made it when people from the community are now mentioning you directly to get an answer. So great work. Thank you for your efforts. And, it's really a joy to watch, and I appreciate it tremendously. So thank you.
Thank you.
And number two, as people have asked questions of you in Slack, just through the rest of this day, I'm sure you guys, may or may not be watching a little bit depending on the time zones, but please feel free to ask questions through chat in this as well. A number of us will see it, and we just would like to have that discussion and hear from other people's experience. So, Ben, Chris, thank you so much for agreeing to do this and just sharing a little bit of your experience. It's encouraging, honestly. So thank you so much.
Well, thanks for having us.
Absolutely. Thanks for having us on. Yeah.
Great, guys. Have a great day.